Hello and welcome. We are glad you have joined us. My name is Amit Neal. I'm a Microsoft technical trainer specializing in security and AI. I am here to walk you through the AZ-305 course, Design Infrastructure Solutions. In this session, we will cover Design and Network Infrastructure Solutions, Part 2. Imagine your applications running smoother, faster, and more securely than ever before. Ready to unlock the key strategies behind resilient network infrastructure? Let's dive into the critical elements that empower modern organizations to deliver and protect the application with confidence. We start with design for application delivery services, how traffic is routed to our applications. Choosing a load balancer without traffic requirements is a little bit like buying shoes without knowing your size. This is a critical decision to make. Azure provides us with wide capabilities to deliver and protect our applications at scale, whether we need smooth connectivity for users or high availability within our end-tier applications. In the Azure Architecture Center, we can find guidance for choosing the right solution based on our requirements. Treat the decision tree as a starting point. It helps us land quickly on solutions that make sense. We start with the traffic type. Is it HTTP-based application, layer 7, or is it TCP/UDP, layer 4? Then we need to understand, is it public-facing, is it internal application? What kind of features do we require? What kind of operations do we run? Do we need a web application firewall, TLS termination, path-based routing, or just raw L4 performance? Where is our app hosted? On virtual machines? On AKS? App services? That will lead us to different solutions. For layer 4, we have the Azure Load Balancer, a perfect solution to create high availability within your tier application or to enforce incoming traffic to be routed into different backend pools. That can be provided either with a public endpoint or with a private endpoint to keep all of our traffic secure. We can distribute TCP traffic over port 80 to our public-facing load balancer onto our front-end VMs. Then we can create high availability within our tiered application with an internal load balancer, assuring that only VMs that are healthy will receive the request. They can also remove them from the pool if they're not healthy and bring them back when they are responsive. This is a great solution when we need simple distribution over layer 4. We can consume the Azure Load Balancer as a regional deployment or as a global load balancer. In that case, we can point from a centralized cross-region load balancer into local, regional load balancers and handle massive amount of traffic distributed into every regional deployment. If we need support for our HTTP-based applications, whether they're public-facing or internal, we can consume Application Gateway. This is a great solution whenever we need to distribute traffic across either backend VMs, app services, and non-Azure environments, including multi-cloud. This is your starting point whenever you're working in layer 7, very suitable for web applications. Some of the scenarios that are supported are path-based routing, so we can define the routing into the right backend pool by its path, or for multi-site or multi-pool domains. This environment supports Azure, non-Azure environments, and hybrid scenarios. So we can make sure that all of our traffic is distributed appropriately to any of our backend applications. It is also coming with a feature to enable web application firewall to make sure that all requests are inspected for web layer vulnerabilities like cross-site scripting, SQL injection, or crawlers. So we can make sure that our applications are not only highly available and reachable, but also protected. Azure App Gateway is coming with a regional deployment, and it will require its own subnet to make sure that we can isolate our load balancer into the virtual network. So we don't need to have a reserved name, but it needs to have its own subnet within our network. No matter where our application lives, within the same network or another connected network, we will be able to route traffic to them. So Azure Load Balancer is for layer 4, mostly for regional deployment. We have seen there is some kind of global distribution approach. If we need a different kind of router that is also for layer 4, basing on DNS, and will not just take the request and forward it through the load balancer, but dynamically allocate the closest endpoint for us and route the request directly into the backend pool, Traffic Manager starting to make sense, especially when we're looking on globally distributed applications. So Traffic Manager is a globally distributed load balancer, allowing us to route in high efficiently, high availability traffic into all of our backend application, support Azure, non-Azure applications, and multi-cloud environments as well as hybrid. How does the Traffic Manager works? Whenever we have a new request from a user, it will perform a DNS query. The Traffic Manager will look at the available endpoints. Depending on your configuration, it can be weighted round robin, it can be by priority or fallback region. It will find for you the best fit for the user from latency and, of course, from your priorities. Will return back the DNS response and will route the users directly into the instance that they need to go to. All right, so we have the Azure Load Balancer and the Traffic Manager for layer 4, and we had the App Gateway for regional deployment over layer 7. Azure Front Door is your go-to solution for layer 7 kind of traffic distribution in a global deployment. It has all the features from App Gateway perspective, beside the regional deployment, because this is intended for global distribution, and comes with accelerated performance for applications and static content delivery. That makes it a strong choice for developers that would like to accelerate the application performance, and of course for architects that would like to deliver high performance applications on top of a globally distribution workload. Azure Front Door is supported for Azure workloads, hybrid workloads, and multi-cloud scenarios. We will choose Azure Front Door when we need to ensure that requests are sent with the lowest latency to the most responsive instance, no matter where it lives. So, all the features that we have like path-based routing and multi-site distribution, TLS termination exist as well in App Gateway as well as in Azure Front Door, but in a global approach. That means that we can deliver and protect global applications, no matter in which region they sit. Whenever we have a new incoming request into the front door, it will help us distribute it into any of our deployed regions. So again, we can create high availability for globally distributed applications, keeping the security in place with web application firewall. It comes with a content delivery network as a built-in, so static content is accelerated in performance. If I have mentioned a content delivery network, this is a great solution to minimize latency when user is trying to reach into your backend application. Instead of reaching all the way into the backend instance, we can perform local caching that will minimize the time that the user will be able to reach it, so they can get their content much faster. This is highly applicable when we have less frequent changes around our content. We can use it for cookies, for storing the session, making sure that all of our users get the content right away. Content delivery network is great when we need delivery for custom domains, file compression, and caching scenarios, making sure that no matter where our backend instances live, our user can reach to a close endpoint and get what they need faster. Now, we go from deliver traffic to protect traffic, designed for application protection services. It is a good idea to take a layered approach for our security. Also, within our network environment, we can make sure to implement multiple security controllers to make it harder for any attacker to break in. Looking from outside in, we can protect our ingress with distributed denial of service kind of protection to mitigate volume attack that are aiming to exhaust our networking resources and prevent our services. Then we can appropriately distribute and protect the traffic with a load balancer and a web application firewall. Maybe we need to do some inspection with an NVA or an Azure firewall. Then, on the subnet level, we would like to filter incoming requests through a network security group. We might choose to isolate the traffic only to be coming over private endpoints and consume without any exposure to the public internet. We can further enhance filtration rules on the NIC level with network security group and make sure that all of our virtual machines are protected from within the network, of course, or any other platform scenarios that are deployed within our network. That way, we can make it harder for any attacker to break in. There's no bulletproof, but as much control as you will have, it will be better. How do we assure secure communication within our infrastructure solutions into our platform managed solutions? If I have a virtual machine that needs to communicate with a storage account, a platform managed service coming with a public endpoint, we can allow the traffic over a network security group. That will allow the VM to reach through the public internet into the public service. What if we don't want to route the traffic over the public internet? That's where service endpoints come into place. We can allow a service endpoint on top of the subnet that will route the traffic over the Azure backbone, our own optical fiber network that connects all of our data centers across the board. To allow private traffic routing, look for the service inside our data center, so the request is never going over the web. We can allow from the private network to communicate with the platform services within the Azure data centers. That will limit the attack surface. And the best part, it's free of charge. Service endpoints are available for a certain amount of services, so we can easily consume them without additional configuration. Just allow from the subnet to communicate with the service. From the platform perspective, in our case, the storage account, it will limit the traffic. We were still using our public IP address for incoming requests, but now it is only receiving traffic from my own private network. No other requests from the public internet are allowed. The platform services that are supported for service endpoints come with a built-in firewall, allowing us to filter the public traffic to only come from our own selected network or public IP address. So not every request is allowed. We explicitly allow the traffic. All right, service endpoints are great when the service is supported and we can still use our public IP address for the platform service. What if we cannot? What if we have a sensitive database that we have to keep over a private network and never should be reachable from the public web? For that, we have Azure Private Link with private endpoints. We can allocate a private IP, a single IP address from our own managed private network and have a one-to-one mapping into a platform service. For that, we have a wide support for multiple services. That means that it will be like deploying the platform service on top of our private network. One IP that is replacing the public IP with a private one. That means that we can mix between infrastructure solutions as well as platform solutions, all being communicated from within the same private network or within peered networks. So all traffic is kept private and under our control. This is a paid service, but will limit to reach to the service only from private IP address, making it the best choice for hardened access architectures. For example, we would like to plan for a platform deployment with app services and SQL databases as a service, but we do not want any traffic to go over the web. We have to keep all on top of our private network. So from the app service perspective, we have the plan that have the integration into the virtual network. But what about the running app? It has a public endpoint by default. We can replace it and locate it with a private IP on top of our own managed network, as well as our backend SQL database can have its own private IP allocated directly into the server endpoint. So we're replacing public endpoints with private endpoints, manageable and secure from network security group, firewall, and of course, web application firewall that can be done on top of the load balancer. I have mentioned network security groups, but what are they? They're actually stateful filters that control incoming and outgoing traffic from our subnet or network interface card. We can associate a network security group or an NSG either to a network interface card that supports virtual machines or private endpoints, or on top of the subnet to control all the components from within that subnet. Every single request that is incoming into our subnet or NICs, or outcoming from the NICs or the subnet, will be validated in front of the network security group's filtration rules. It will look at source, destination, port, and protocol. We can either allow or deny the traffic, so we can maintain the appropriate communication between the resources. Why network security groups are important? Because by default, all traffic is allowed within all the subnets within the same virtual network. There is no built-in filtration. If we would like to prevent lateral movements, for example, we can isolate and restrict, assure that only components that need to communicate with one another can, and restrict any other traffic. There are some built-in rules that help us protect the network even if we haven't done any customized configuration. Network security groups are great when we just need basic filtration inbound or outbound from a NIC level or subnet level. But what about our virtual network, our entire network topology? That's where Azure Firewall plays a critical role. This is a firewall as a service, platform managed solution that is allowing us to protect networks in Azure, on-premises, and multi-cloud environment. We can use one firewall with unlimited scalability to protect any network wherever it is. Azure Firewall is not only about filtration, it also supports network address translation for secure access from the public IP of the firewall into our underlying private IPs, or of course, outbound secure connectivity to the internet. It supports threat intelligence rules to filter and deny malicious requests from IPs and domains. Then we can maintain our own firewall policies for networking level and application level filtration, making sure that all of our operations that are not HTTP-based for TCP, UDP, RDP are protected. We can maintain firewall policies in a hierarchical mode, meaning to have a global-wide organizational rule policy and dedicated child policies for each workload that require more specific filtration rules or additional policies for netting, for example. It is enough to have one firewall, unlimitedly scalable, deployed on top of the hub. It will immediately restrict all traffic coming from public web to all of the connected network through peering, VPN, or express route, so we can easily protect all of our workloads at scale. When we have web-facing applications, we are vulnerable for web layer attacks. Azure Web Application Firewall helps us protect web applications from common web attacks like SQL injection and cross-site scripting. It comes with a built-in protection using Managed OS rules and is deployed within a service such as App Gateway or Azure Front Door to make sure every request is inspected, and if there's a risk, it will mitigate it. In a typical design, a web application firewall focusing on inspecting and protecting HTTP-based traffic, while Azure Firewall and Network Security Group handle the broader network-level protection. In addition to the built-in rules, we can define our own custom policies tailored to our own environment. By creating those, we can address unique or emerging threat patterns identified within our own environment, providing targeted mitigation and enhancing the overall security for our web-facing resources. If search engine crawlers or malicious bot hit a public website, Azure Web Application Firewall blocks automated SQL injection and script scanning requests before they reach the apps. Another aspect of our perimeter protection is distributed denial of service kind of protection to mitigate DDoS attacks. Those kind of attacks leverage public endpoints that are not protected, sending massive amounts of requests into your networking resources in attempt to exhaust them and prevent the service. DDoS protection standard allowing us ongoing monitoring all of our public IP addresses that are part of this plan, allowing us to inspect the request verify if they're valid or not, filter them when they're not valid, or if they're coming in massive amounts that potentially can exhaust networking resources and prevent our service. The mitigation is automated. Whenever the threshold is met, it will kick in, filter the request, keeping your workloads up and running. Think about your personal lives. We have so many smart devices nowadays. Our smart TV, our virtual assistants, of course, our smartphones. If we don't consider endpoint protection, our devices could be leveraged for that kind of attack. So think about your work devices, your personal devices. Make sure you have endpoint protection in place. When we need to manage a virtual machine, Windows or Linux, a classic approach is open RDP or SSH over public IP and allow the access. This is not a best practice. If you leave your management ports open, you will get attacked. Brute force attacks are super popular, targeting those management ports for unprotected workloads. If we would like to avoid those kinds of attacks, we can revoke public access into our virtual machines altogether, meaning to eliminate public IP and keeping them only with their private IP address within the network. How do we connect to them? We have Azure Bastion for that, a modern solution platform-managed jump host, allowing us to securely connect over SSL, browse into any virtual machine. We will access the public IP of the Bastion and initiate a secure session on each and every VM that is allowed to connect through the Azure Bastion. What do we need in order to allow it? It needs to live within the same network or on a peer network. That means that we can centralize the management on top of the hub, deploy the Bastion on the hub, and you can manage any connected virtual machine that is sitting on a connected network. That way, we minimize the attack surface and only allow authenticated users to securely manage and connect their virtual machines. We can even further enhance the protection by configuring granular rules from network security group perspective. For example, to only allow to manage certain machines within the Azure Bastion. So the connectivity will be on top of the public IP of the Bastion, but the session for RDP or SSH will be initiated from within the private network. This is a great way to prevent brute force attacks. If your VMs are not publicly accessible, your management ports are closed, attackers cannot target them. Sometimes we do need to connect over RDP, SSH, or SQL management ports over public IP to our virtual machines. In that case, we highly recommend to restrict the time frame that request will be allowed, again, to minimize brute force attacks. As long as we have a network security group or a firewall where we can manage rules, we can implement just-in-time access for virtual machines. How does it work? It will enable a blocking rule by default, revoking access into the management ports. Only by request, we can allow the access from specific IP addresses even, or per request, for a temporary time frame to allow connectivity into the virtual machines. It is done by adding a higher priority rule to your NSG or your firewall, that allowing us to minimize the time frame that the management ports are open, keeping them much more secure. By the way, this is also working for AWS VMs. Let's review what we have learned. Let's take a BI enterprise application, for instance, that we're looking forward to migrate. We have the following requirements. This application is categorized as mission critical and requires high availability provisions with an SLA of 4 nines. It also required disaster recovery provisioning with 10 minutes of recovery point objective and 2 hours of recovery time objective. We need to establish a hybrid connectivity from on-premises into the working app, leveraging high-performance scenarios with a failover plan. All traffic between the on-premises locations and the Azure virtual networks must flow via a single virtual network with traffic filtration. We would also like to minimize cost and management effort wherever we can. Think about the solution. How would you deploy it? Let's see a sample solution. We start by defining our Azure environment and, of course, our on-premises. All incoming traffic should be isolated into the perimeter. That will be our virtual network. To create highly available redundant connection, we can use ExpressRoute. For failover that is less expensive, we can leverage Virtual Network Gateway, VPN. To make sure that all requests are inspected, we can use Azure Firewall. Then, after going from on-premises into the Azure network perimeter, we can define our virtual network that will run our workloads, the business enterprise application. We will start by receiving all the requests into our virtual network. It will first be handled by a subnet protected with a network security group. Then, we can go ahead and deploy Application Gateway to manage web layer requests. We can protect those requests with a web application firewall. Then we will forward the request into our front-end tier. Then again, we would like to protect it with a network security group. Our front-end tier can be hosted on top of virtual machine scale set. Then we will forward the request through an Azure load balancer to assure high availability and meeting the SLA requirements. We will forward the request into our middle tier. Of course, we would like to protect it with a network security group. For the middle tier, we can also consume Azure Virtual Machine Scale Set. That kind of deployment is highly available and scalable. Then we have our backend tier. Of course, we would like to protect it with a network security group. We can host our backend tier on a SQL database through a private endpoint. In this session, we have covered design for application delivery services and design for application protection services. This concludes our session. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic at Microsoft Learn at aka.ms/learn. I'm Amit Neil. Happy learning.